Today we're with Craig Berntson. How are you?
Hi, great.
Craig, what do you do?
I work for 3M Health Information Systems in Salt Lake City. It's a division of 3M that everybody knows. If it weren't for Post-it notes, you wouldn't be able to run your business.
Sure.
But we have a division based out of Salt Lake that creates software for hospitals.
Okay. And we're here at DevLink in Nashville, Tennessee, and I know you're talking tomorrow, I think?
Tomorrow?
On continuous integration.
Yes.
What is continuous integration?
Well, if you think about your development process that you go through, multiple developers, even if you're a single developer, it's going to help you. But multiple developers, you've got all this code you're writing, you've got to take it and put it together. You want to make sure that you can always reproduce the same build all the way through. People say, well, if I have source control, I can do that, just check it out. Well, maybe is the answer.
Right.
So what that is an ability, first of all, to take all these different pieces, put them together, make sure they build, run tests on them, hopefully your unit tests, and at any moment in time, anybody on the team can check typically a web page to find out what the status of the current build is.
Okay.
And normally it's be continuous. That means that you do a build whenever somebody checks in code. In reality, you probably don't want to do that, but you can get it to near continuous.
Okay, so the integration part is automating this whole build process, testing process, and the continuous part is doing it each time or almost each time somebody checks in.
Exactly,
Right?
yes.
All right, and let's start off with why is that an advantage?
Well, the advantage is that you can find bugs earlier in your code. I'm sure everybody's written code that another developer takes and uses perfectly the first time, and everything happens to build and work.
That's the only time I've ever had code is.
Yeah, I know we're all like that. So the first advantage, obviously, then is you can then test as your piece gets fit into theirs that they still work, and that you don't have side effects that you weren't expecting. That module that the third developer has created doesn't work now.
Okay, so you can run your unit tests.
You can run all those tests, but you can even expand that out. You can even go out to do things like there's a testing framework called Fitness, which does usability type testing.
What do you mean by usability type testing?
Well, do things work from the user standpoint that they would think they'd work from?
Okay.
So you can run tests for fitness, not just say NUnit or MS test type tests. You can even go so far as to actually simulating a deployment. So you can have it create all of your install scripts and everything, and then simulate a deployment to make sure that all works correctly.
Okay. And the idea is to catch problems early on rather than later.
Oh yeah, I mean we've all seen the graph. As the further along in the process you get to find a bug, the more expensive it is to fix it, and probably the longer it takes to fix it.
Okay. And you said before that it's maybe not a good idea to do that every time somebody checks in. Why is that?
Well, imagine if you have 50 developers and all checking in code pretty close to each other, you're going to get 50, 60, 70 builds a day maybe. That's just, you're going to start to get into problems where it's going to stop and block another developers from getting tested and compiled. It's just going to be more trouble than it's worth. Plus, you're going to get these giant log files that get created at the end of the build to tell you what's going on. So you kind of have to balance, figure out what's good for people depending on your team. My recommendation is when you get started, just do it daily. Just don't worry about continuously, just do it daily. Most developers don't like change, and going to continuous integration is a big change in the way most people function.
Right. Okay, and what, I'm a .NET developer.
Okay.
What are some tools that I can use to make this happen?
Well, the big one obviously is Microsoft's Team Foundation Server and Team Suite, but it can get very pricey, especially if you're in a small shop. Hey, I work for Fortune 100. We don't use Team System or Team Foundation Server. So probably the best known out there is CruiseControl.net, which is a free tool that comes from Martin Fowler's company. The problem, again, it's just like most open source software, documentation's lacking. So it takes a little bit to get it set up and built. The session I'm doing here tomorrow walks through how you can set up your build and get started with it. And I go as far as integrating unit testing into that and showing how you can get started.
All right. Now, why did you choose this open source tool over
There's
TFS?
plenty of materials out there on TFS. There's lots of stuff. There's books, there's blogs, there's websites, there's Microsoft stuff. There's very little on how to do it on the cheap, such as with TFS and NUnit or MS Test.
Okay.
And that's the route we went when we set up our CI builds. And so I thought, well, let's see if we can take this and develop a conference presentation around it. And incidentally, it's just now becoming public. A couple of weeks ago, I signed a contract with Manning to co-author a book on continuous integration using the free tools.
Okay.
There's another tool out there that is free for the small shops. They charge a licensing fee in large ones. It's called TeamCity from JetBrains,
Okay.
which is a nice GUI. So it takes a lot of the having to deal with XML file type stuff out of the picture and gives you a GUI to run it in.
Okay, that's nice. So the cruise control is very much configuration driven.
Cruise control is configuration driven. You've got to know how to edit XML, although there is a free XML editor out there for it
Right.
to get into it. But that's the way a lot of people start and what my session's geared on.
All right, so just walk me through the process of, as a developer, what happens to kick off a build?
Well, there's two main ways, or three ways you could really kick off a build. One is manual.
Okay.
Say with cruise control, you've got a web page that you can go to get the stats of any build. There's a button right on there that says build this.
Okay, and what does it mean to build?
Anything that you define it to be. It can be compile the code. Typically it's compile the code, run some tests. You could run fitness tests, as I said. You can create deployments. There's a number of things you can do in a build.
Okay.
So the other ways that you could do that are at a specific time.
Okay, so schedule a daily
daily build,
every
or
night at some
every
time.
night at whatever time, or weekly, or however often you want that to run. The other way, and this is where it gets truly continuous, is every time somebody checks in code into your source control, there's a little agent out there running that detects when that has been checked in, gets the code out, and does the build. Again, depending on how you've defined it. Typically, if it's continuous, you're not going to run all of the tests and do a deployment every time somebody checks in code.
Okay, all right, so you might have your daily build might be more thorough, might include the deployment.
Yeah, or maybe that's only weekly, however often that you need to do that. Some other things you could possibly do are you could run FX cop on it, or style cop. You could run Sandcastle against it to create developer documentation. There's a number of things you can do in that build process.
Sandcastle used to be NDoc. It's the sort of same thing.
Well, kind of. Yeah, NDoc was a public domain thing that's no longer being updated.
Right.
Sandcastle's from Microsoft, but it's still free.
Okay, all right. So is there a compromise halfway between every time somebody checks in versus doing it every day? Is there some way?
You can do it however often you think you need it in your environment. Like I say, I recommend every day to get started, because that way it doesn't seem so invasive to the developers. Plus, they have to change a little bit the way they're working. A lot of times developers tend to check out code, leave it checked out for long periods of time. To make this work, you need to check it out, modify the code, get it checked back in. So again, each environment's going to be different. So there's no really hard and set rule for how often you're going to do this. But continuous, in a big shop probably is not the way to go every time somebody checks in code, but every hour or every 10 minutes or however often you think you need to. And you might want to change that period depending on what step in the process your project is at. Early on, you're probably not going to have as much code as later in the process.
So it'll take longer.
It'll take longer to build, but you may want to do it more often.
Okay, all right. All right, so when you do this build, it could include compiling code. That compile can fail. It'll include running unit tests or any automated tests. Those tests can fail. You could apply something like FX cop, and FX cop may flag some warnings or some errors based on bad code. What happens if something fails during this build process?
You can... Well, typically the way it is you have a number of different feedback mechanisms that you can use. I've heard of people buying those electronic signboards. So when something fails, the electronic signboard in the office clicks. Yeah, it kicks on. People know. I know. I've heard of people getting like strobe lights that go off if the build fails. Yeah. You can send a text message to somebody. You can use Twitter to send out a message that the build's failed. typically, the feedback mechanism on these systems is some sort of a web page that you can go to and find out. Cruisecontrol.net actually has a little tray icon application that you can get and uses the same typical red-green colors that you get with unit testing. So if something goes wrong, it turns red. And a real geeky thing that people could use is something called an ambient orb.
Okay.
That basically is, it's an orb, so it looks like a ball, but it has LEDs in it, and it's wireless. So depending on what message you send to it, changes the color that's being glowed by the orb. So you can have it glow green when things are well, and turn red when things work out right, or even if you have multiple builds in a row that keep failing, you can have it keep a deeper and deeper and deeper red color. So you can stick that out in the office somewhere where everybody can see it, for example.
Oh yeah, okay. So I think probably a lot of people aren't investing hardware into this, but sending a text message, sending an email, that sounds like you need that feedback. Having a web page, that's more passive. You have to actually go check the web page.
Well, that's the nice thing about, yes, but the tray icon is nice too, because it polls what the latest status is.
You get instant feedback.
You get instant feedback.
All right, so what do you do in your shop? Let's say I check in bad code there, or good code, but when integrated with your code, it breaks. It breaks a unit test as a side effect. So therefore, then the build does not succeed.
Right.
Does everything stop then? Or
Well, it depends on how bad that break is. If it's a major component, everything might stop, but it's probably unrealistic.
So what's your process
Whoever's broken it has to go fix it.
All right,
and
so
then,
things don't stop, but can you still check things in?
yeah, you can still check things in. It doesn't, because again, it's just like anything else, checking it into source control.
Sure,
Right?
yeah.
So obviously, if I break the build and the guy sitting next to me checks in code, it's going to build, it's still going to be broken. So
Yeah, so
I fix it.
So there's no good information coming out of that automated build process while your code is broken. Once you've broken the build,
I wouldn't say there's no good code information, because
the fact that it's broken is not useful information to me because I already knew it was broken.
Right.
So I don't know if I broke it more.
well, but it can run unit tests on his code
Okay.
and tell us, is his code doing okay? I'm still breaking it.
Okay.
And his code may not run, depending on how many dependencies there are on each other.
Okay.
But
So
his code may run and pass his unit test, but there may be some integration test then that fails.
I see. Okay. So you can get more granular to see exactly
Yeah.
what's failing.
Or he may just hold up till my build fixes. Obviously, if you're, a lot of shops say, well, I'm going to set this off to run at 2 a.m. when they get started, because we know that pretty slim chance people are going to be in there working on it.
Right.
Well, you don't want to be the guy that's broken the build at 2 a.m., especially if your rule is you break it, you're going to come in the office and fix it. So what you should do is run your unit test before you check in the code. Make sure it works.
Okay. Yeah.
Then check it in. So at least your code now works. It still may break integrating with somebody else's code,
Yep.
because you probably haven't unit tested all that stuff.
Correct. Yeah. So where can we find out more information about continuous integration in general and maybe cruise control in particular?
Just go out and search for cruisecontrol.net.
Okay.
You can find it. I actually have a white paper on my website.
Which URL?
It's www.craigbernson.com. That's CRAIGBERNTSON.
Okay.
It's going
to appear right here.
Okay.
On the screen. And then it's going to collapse like this.
Yeah. Okay. Great. But we've got it right now.
All right.
Click on articles.
Okay.
And there's a white paper there that gets you started with doing this kind of stuff. And again, start out simple. I mean, when I first started researching it, my build box was a 6-year-old Gateway laptop with 512 mega RAM. And I just ran it on XP to get started.
So you don't need a whole lot of hardware to do this stuff.
Well, eventually you're going to want to, because you want these builds to run as quickly as possible.
Okay.
But to get started, especially if you're doing it daily, you don't need big hardware.
I see.
I propose that as a best practice, you don't run it on the same machine that, say, is your source code repository. Because if that machine fails, you still have a copy of the latest code on your build box. Just as a backup.
Right.
So, yeah, you can start out on the cheap. I mean, the only thing you're really going to have to pay for to get started is your hardware and your license for Windows. Everything else that I talk about is free. Except, of course, the ambient orb, it's $100, but you can get feedback for nothing.
That's not required to do.
No. But to get started, it's free, what I'm talking about. I mean, And things like your VB or C# compilers, they're free. They're part of the .NET framework. You don't have to install Visual Studio on the server. You just get the free framework. Install it. And it uses MS Build to use the build, so that's free also.
All right. Well, Craig, I really appreciate you talking.
Oh, thank you.
All
right, thanks.
And
Friends at Technology, the best way to meet them up is to go to a conference.